So sometimes when you're doing probabilities, it's really too big to write out the whole sample space or even many ways to do the event. And so sometimes mathematicians and statisticians have come up with ways to calculate these um, number ways something can happen using formulas. And we actually have two different types of formulas that we can use. One is called a permutation and one is called a combination. To show you how those work, we're going to look at just an example and kind of talk about how do we calculate um, using a certain rule to come up with these things. So let's say some random experiment has 100s and 1000s of possible outcomes. We want to figure out how many total outcomes there are in a particular experiment. And so this is actually known as kind of the multiplication rule that allows us to kind of use this. We'll get into permutations and combinations because they kind of fall from this rule, but it kind of can be used in anything. So as an example, let's look at the game of Yahtzee. And what is the probability of rolling a Yahtzee, which is all 5 dice are exactly the same? So there are 6 sides on a die. So if you think about each die as one little kind of outcome, and I actually like to put horizontal lines here that I'm going to fill, like I did here, and then you put in how many ways can each one of these things happen. So the first one, you have 6 ways of getting anything. Then you also have 6 ways of getting the other thing, and then 6 and 6 and 6. And if you think about going back to our rules of probabilities, you can actually just multiply these numbers all together. This is known as the multiplication rule. And you just multiply these 5 numbers together, which is 6 to the 5th. So this tells you how many possible outcomes there are when you roll in a die. Now, for a Yahtzee, you either get all 1s, all 2s, all 3s, all 4s, all 5s, or all 6s, and there are 6 ways that that can happen. So your probability of a Yahtzee is 6 out of all the different possible outcomes. Again, you can change it into a decimal and reduce the fraction if you want. So this is known as the multiplication principle. If there are n1 ways to choose item 1, n2 ways to choose item 2, and so on to n sub k, then the total number of choices overall is n1 times n2 times n3, all the way multiplied up to nk. So as an example, how many Comet IDs are possible? So if you look at our Comet ID at the college, you have 2 letters followed by 3 numbers. So we could have, again, put the dashes for each letter, there's 2 of them, put a dash for each number, and then realize, okay, actually you can have numbers or letters in the last ones. So you could have 26 for the first letter. Since you can repeat letters, you can have 26 for the second letter. For the third one, since you can have numbers or letters, you can have 26 numbers and 26 letters and 10 different numbers. So you have 36 different numbers you could put here. 36 different numbers or letters you could put here, and 36 here. So then you can notice I just multiply all these numbers together, and that tells me how many Comet IDs are actually available here at the college. And so you can either write that as 26 times squared, which is 20, and then 36 cubed, or you can multiply it all out. If it's case sensitive, then things kind of get a little different. And then instead of being 26 letters, there are now 52 letters in the alphabet because there's lowercase and uppercase. So you've got 52 for the different letters, and then because you've got the 10 numbers, you've got 62 numbers or letters for the other 3. And then how many are possible for each individual? Well, usually we use your first initial, and usually we use your last initial. So usually you'll have 1 choice here and 1 choice here, but then these 3 can be any combination of numbers or letters. So it's 36, 36, and 36 for these, and 1 times 1. So that's how many different ways. You can do this with lots of different things. How many license plates, how many phone numbers. All of them would be put a dash for how many different things you would have, and then above the dashes put how many different ways that can happen. As an example, let's say we have 3 tables, 5 gliders, 6 cushions, and 2 umbrellas, and we want to know how many different sets can we put together here. Well, again, I would put a dash here to say tables, gliders, cushions, and umbrellas. And then there are 3 choices for the tables, 5 choices for the glider, 6 choices for the cushions, and 2 choices for the umbrellas. So multiplying those 4 numbers together gives me 180 different sets. And how many ways can you line up 6 people? Well, there are, again, 6 people, so put a dash for each one. And then there's 6 ways to put the first person. But once you put that person, there's now only 5 ways to do the second person, 4 ways to do the third person, 3 ways to do the next one, 2, and then 1 way to do the last person. So there are now, multiplying those together, 720 ways to line up 6 people. This is actually known as a factorial. Anytime you want to multiply, like start in a number and then reduce by 1 all the way down to 1, it's called a factorial. The symbol for factorial is n exclamation point. We read this as n factorial. N factorial is always n times n minus 1 times n minus 2 all the way down to times 1. So 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 12 factorials would be exactly the same. Your calculator actually has factorial in it. If you go into the math button and move over to probability, you'll find the factorial button in there. It just looks like an exclamation point. So the next thing is if you happen to have if you have a factorial over a factorial, you can actually do some things. 30 factorial is 30 times 29 times 28 times 27 all the way down to 1. 28 factorial is 28 times 27 all the way down to 1. And you notice all these numbers will cancel each other. And so you just get 30 times 29. So that's a quick way to do some multiplications with this. Now I want to actually show you how you can do combinations and permutations. A combination is where the order doesn't matter. Oops, can't spell combinations, obviously. Combination is where your order doesn't matter. And the formula for that, and the way we kind of write it, is you can do combination of n objects, choosing r of them, and what that'll equal is n factorial over n minus r factorial times r factorial. So that's if your order doesn't matter. And now what we want to look at is instead looking at when the order does matter. And so when the order does matter, then it's called a permutation. And so permutation is where the order does matter. So the way we do permutations, we use a P for permutation. And the formula for that is, again, you're going to take n objects and choose r of them. And that's going to equal n factorial over top of n minus r factorial. And so you can see these are very similar formulas. Combinations, because order doesn't matter, takes away the order by doing the r factorial. So you're going to get a slightly different number, smaller number here than you would with the permutations. So now what I want to do is just show you how this works and how we can do some problems with this. So let's take a couple of examples of combinations and permutations. All right, so as an example, and I'm going to type it because my handwriting is not the best on there. So what this will say is the science club consists of 18 men and 12 women. 5 members are chosen to staff the club's booth at the Science in the Park. All right, and what I want to know is how many ways can the 5 members be chosen if they can be any members? All right, so we want to figure this out. So of the 18 men and 12 women, that would be 30 different people. So we have 30 different people we're choosing from. And we want to choose 5 of them. And then the next thing that we have to think about is, does order matter or not? Does it matter what order I pick those 5 people to staff it? Are they going to be a very specific place, or are they going to not have a very specific type of job? And since it doesn't matter, then we would actually have order doesn't matter. So it's a combination, because it doesn't matter what order you pick somebody in, they're all going to do the same job. So I'm going to write that down. And so we have combination of taking 30 people and choosing 5 of them. So the formula is n factorial, which n is the big number, it's a 30. So n factorial over top of n minus r, so 30 minus 5, factorial, times r factorial, so times 5 factorial. And so think about it this way. Let's find out what these things are. You can't multiply these numbers together. You have to find what the 30 minus 5 factorial is and find what the 5 factorial is first, and then multiply those together. Think of it as kind of like a square root where you can't just multiply the square roots together. You have to do the calculations. So 30 minus 5 is 25. And again, you can use your calculator to find out what these factorials are, or you can go ahead and do it by hand. So 30 factorial is, again, 30 times 29 times 28 times 27 times 26 times 25 times 24, all the way down to times 1. 25 factorial is 25 times 24, all the way down to 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And so one thing I want to point out to you is that 25 here and 25 here can be canceled. 24 and 24 here can be canceled. In fact, all of these can be canceled with all of those. So you really only have to multiply 30 times 29 times 28 times 27 times 26 on your calculator. And then multiply 5 times 4 times 3 times 2 times 1 on your calculator. So 30 times 29 times 28 times 27 times 26 is 171,00720. 5 times 4 times 3 times 2 times 1 is 120. And then you can go ahead and do the division. So 171,00720 divided by 120 comes out to be 142506. So that's how many different combinations you have of this problem. So now let's look at another problem. So this time, let's look at let's say a toddler is playing with some magnets, some magnetic letters on the refrigerator. He has the letters L, T, A, B, and E. If he arranges the letters in a line to make a word, what is the probability that the word table will come up? All right, so in this case, we are going to have 1, 2, 3, 4, 5 different objects that we're working with. So there's 5 objects, and we're going to choose all 5 at a time. And what we have to think about is a combination or permutation. So if I have L, T, A, B, E, that is very different than L, A, T, B, E, and very different than L, A, B, T, E, and all the different combinations you could possibly do. So this actually does have the order matters, because what order you put those letters in makes either words or not. So order matters. So since the order matters, this would be a permutation. So it's a permutation of choosing 5 objects and picking all 5 at the same time. So permutation is n factorial, which is the first 5, over 5 factorial, n factorial minus r factorial. So over 5 minus 5 factorial. So then what we notice is we've got 5 factorial in the top over top of 5 minus 5 is 0 factorial. And then you go, wow, you're dividing by 0. So this is where the important thing to note is that 0 factorial turns out to be the number 1. It's defined to be the number 1. So anytime you see a 0 factorial, you can replace it with the number 1. So what you have is 5 times 4 times 3 times 2 times 1 on the top, over top of 1 in the bottom. And that gives you 120. So there's 120 different words that you could make. They're not all the word. So now we want to look at the probability of the word table. And table, there's only one way out of those 120 to get the word table. So the probability would be 1 out of 120. And that's how you do permutations. And that's how you can use permutation combinations in your probabilities.